looking at sign C, we're looking at demonstrate understanding by calculating conditional probability and independence using everyday examples of events based on the context of the problem. Okay. 11. The probability that Ella exercises is 0.58. Probability that she exercises and is overweight is 0.20. Find the probability that Ella is overweight given that she exercises. This formula is awkward. Change it. So I'm going to change it. We use the formula probability of B given A equals the probability of A and B over the probability of A. So the probability that Ella exercises is 0.58. The probability that she exercises and is overweight is 0.2. Find the probability that Ella is overweight given that she exercises. So remember, circle your given. B is the 4. So B is the 4. A is after. So I want A and B, so I need to find and. Probability that Ella exercises 0.58, 0 and there. The probability that she exercises, oh, here it is, and is overweight is 0.2. Over the probability of A, well, my probability of A, she exercises. Probability that Ella exercises is 0.58. 0.2 divided by 0.58 is 0.344. One thing to keep in mind. This answer should always be less than 1. You cannot have a probability greater than 1. Okay, so this should always be less than 1. If it's greater than 1, it means you probably flipped your A and B and A. So that's a good thing to look out for. Alright, looking at number 12. The probability that children eat chicken nuggets and drink apple juice is 0.72. The probability that children eat chicken nuggets is 0.57. Find the probability that children drink apple juice given they just ate chicken nuggets. So again, I'm going to change our formula. It'll be right on the test. Probability of B given A is probability of A and B over the probability of A. So, I'm going to find my given. Find the probability that children drink apple juice given. B comes before. B is that children drink apple juice. Eating chicken nuggets is A. So I'm finding the probability of drinking apple juice given chicken nuggets, right? So I'm going to find the probability of chicken nuggets and apple juice over the probability of chicken nuggets. Well, the probability of chicken nuggets and apple juice, chicken nuggets and drink apple juice is 0.72. How is wrong with you? There's so many issues with this. I'm going to change the number. Just go with it because otherwise it doesn't make sense. We're going to change that to 0.97. Why not? Right. So the probability that they do and is 0.72. Then I need the probability of A. Why they just ate, the probability of eating chicken nuggets is 0.97. I'm going to divide both of these. I get 0.74. All right, number 13. Athletes are training for the Olympics. 78% of the athletes lift weights, and 34% lift weights and run on a treadmill. Determine the probability of the athlete lifting weights and running, given that the athlete lifts weights. So here's my given. Again, B comes before, so running is B. Lifting weights is A. So when I'm doing my formula, the probability of, again, I'm really finding running, given they lift weights. And again, it's the probability of A and B, so lift weights and run over the probability of A, so over the probability of lift weights. If it's more helpful to you to write in the full words instead of just A and B, use that. So I want my lift weights and run. Lift weights, that's just lift weights. Here, lift weights and run. 34% of them. And again, for these, I can use the percent, that's fine. Then on bottom, I just have lift weights. 78% of them lift weights. Again, I'm just going to divide these. So I have 34 divided by 78, and I get 17 out of 31. And I want that as a decimal, so I'm just going to go to menu, number, convert decimal. Enter. I get 0.44. Really, either of these would be fine. I'm pretty sure the multiple choice is a little meter right there. It's 0.44. The multiple choice on your test would be a decimal. Okay, so make sure you know how to convert to decimal. All right, looking at number 14. The probability of ordering a sandwich, given that you ate chips, is 0.51. The probability of ordering a sandwich is 0.32. And the probability of eating chips is 0.24. Is eating chips independent of ordering a sandwich? Now, this is a whole different type of question. A lot of people will still try to determine what the probability of B given A is for this. Okay, that's a big mistake that a lot of students make. Okay? It's not. It's asking, are they independent? So remember, our formula. Probability of, let's that out. B given A equals the probability of A and B, or the probability of A. Well, again, probability of A and B, remember, and means multiply. My probability of A's divide away, so equals the probability of B. So the probability of B given A has to equal the probability of B. So again, let's figure out what those probabilities are. Where's my given? Given, B comes before, ordering a sandwich is B, eating chips is A. So the probability of B given A equals 0.51. That's my given sentence. Now I need to find the probability of B. That's what I want it equal to. Ordering a sandwich. Probability of ordering a sandwich is 0.51. 0.32. So what do I say here? Well, 0.51 does not equal 0.32. Remember, when they aren't equal, it is dependent. All right, let's look at our last question. What is the probability that the total of 2 dice will be greater than 6, given that the first die is 3? Remember, on here, our top is our first roll, and the side is the second roll. This is kind of like our table problem. I am given that the first die is a 3. So I'm only going to be looking at the numbers where I have the first roll being a 3. What's the probability that the 2 dice will be greater than 6? 2 dice will be greater than 6. Well, 4 is not greater, 5 is not greater than 6, 6 is not greater than 6, 7 is greater, 8 is greater, and 9 is greater. So there are 3 numbers greater than 6 out of these 6 options that I'm just looking at. And 3 out of 6 reduces to 1 out of 2. All right, and that is it for target B. Go ahead, look over that, and then do target B.